So welcome all of you at TNG, Technology Consulting. It's nice that you're all here for Saturday and listening to Venkat Subramaniam. And I don't want to spoil something, so just Venkat, let's start.
Very good. Thank you. Well, I'm really thrilled to be here, and also Ben joins the ranks of one of those few people who can actually say my last name really well. So I'm very impressed already. Thank you. Let's get started. I want to talk about JavaScript, rediscovering JavaScript. I've given this talk quite a few times. There are things in here that you're familiar with. Hopefully there are things here that would kind of reaffirm some of the things and also maybe expose a few things that maybe you've considered but not have gone into deeper. So best time to ask questions or make comments is when you have it. So please don't wait till the end. Anytime is a great time. It's not an interruption at all. Anytime is a good time for questions, comments, anything you want to share about, don't hesitate. So let's talk about, first thing first, what's wrong with JavaScript? Where do we start? I have this assertion that JavaScript is like an infant. It's beautiful to play with, but when it starts crying, you don't have a clue why. And that's been my experience. It's a beautiful language. I like JavaScript. In fact, I only talk about things I like, and I really like JavaScript. But just because I like something, I don't only continue praising it. I also say things I don't like about it, kind of try to be a little objective. Well, the first thing about JavaScript is inconsistencies. Between different browsers, different implementations, there's always this inconsistencies between versions, and that seems to hurt us quite a bit. This is one of the reasons why we have such a number of tools that just simply try to save us from all these differences and inconsistencies. Such a poor name for a language. I mean, would you do this? Would you name your kid after somebody in the neighborhood who's very popular at that time? So it's kind of sad that they took on the name JavaScript, and now they are trying to distance from the name Java, which is kind of weird. But they did take on the name JavaScript. They wanted to ride along, which also causes quite a number of confusion for people. Well, I know Java, so I don't have to really learn JavaScript, right? No, actually wrong. It's very different from in a lot of different ways. It's one of those languages which is probably the most misunderstood languages ever, in my opinion. I'm still learning JavaScript, honestly, because there are so many things that are in the language I keep discovering. It's one of the misunderstood languages. If you go to somebody and say, hey, here's a language, programming language, what do you want to do? And they may ask you, is there a training I could take on this language? For some reason, people don't want to take training in JavaScript. They feel that it's beneath them. I mean, if you go to somebody and say, I want a training in JavaScript, they're like, what is wrong with you, right? So it's a language that is misunderstood, and we tend to really hide that and be quiet about it. And that is one of the really big disadvantages of JavaScript also, is that it is confusing, it is misunderstood, and yet people don't take the time to learn it. There are many, many bad examples on the web. In fact, I'm going to actually change this a little bit. I used to say that people read bad JavaScript from the web and used it. That has significantly changed now. I've got good news for you. People don't read bad JavaScript from the web and then code it. They just copy and paste it now, which is even worse. So that same exact poor copy gets copied over many, many times, and that's one of the other problems with it. But besides all of that, there are some really good things about JavaScript. One of the things that really captivates me about JavaScript is it is quite powerful. It's amazingly powerful. It's one of the most powerful languages I know personally, and I really like it for the power it provides. From the point of view of coding, I used to be very fearful of dynamic typing. But over the years, I've gotten very comfortable with dynamic typing. JavaScript is not only dynamic type, it's also weakly typed, which means that the type checking is not going to happen very much, and it's garbage in, garbage out. That part can be a little troubling. We got to be very careful about it. Somebody tweeted this the other day, and I thought that was a really appropriate way to say it. They said JavaScript is weakly typed. That means every week you wonder what the code is doing. That's one way to think about it too. But the point really is it's a weakly typed language, absolutely, as the word weak not being very powerful. But it's very dynamic type and weakly type. That's one of the biggest strengths. It's very flexible, and JavaScript is ubiquitous. I mean, a few years ago, a company in Denmark called me and said, we want you to come and talk about software design. And I said, I'll be delighted to, so I agreed to come talk about it. We had several months, and then suddenly, about a week before the talk, they called me and said, we forgot to tell you, we got a little bit of a trouble here. It's like, what is it? Well, we got 3 groups of people in the room. 1/3 is Java programmers, the second third is C# programmers, and the third is the PHP programmers. How in the world are you going to talk to all these 3 different groups? Well, if you use Java, the C# programmers and the PHP programmers are going to be really angry. If you use C#, the rest of the groups are going to be angry. So I was kind of wondering, I said, don't worry about it, I'll take care of it. And then on the flight, I was thinking, how am I going to give a talk when you have 3 different groups of programmers? And then it suddenly dawned on me, I actually can do this. So I went there and started talking. And I just used JavaScript. And by doing it, I made everyone angry in the room, which is really nice. So you could be equal opportunity, to make everybody angry. And the point really I'm making is JavaScript is kind of the English of the programming language world in a way. We all kind of speak broken English from time to time. My English is pretty bad in a lot of ways. I kind of learned it very late in my age, but I can get along with most part of the world knowing English that I know. And that's kind of like JavaScript. You could be talking to anybody, but everybody kind of understands JavaScript to some stage or the other. That's kind of like the lingua franca, the common language we can actually use, which is pretty darn good. And of course, it has supported a functional style of programming for a very long time. I don't want to ever make the connection to functional programming, because JavaScript is usually considered to be a dysfunctional programming language, not a functional programming language. But JavaScript has had functional style of programming from the day one, which is kind of strange because a lot of people programming in JavaScript were programming in other languages, C++, Java, C#. All these languages pretty much provided imperative style of programming and object-oriented style. None of these languages gave us a functional style of programming until very recently. So a lot of programmers using these mainstream languages, when they had to use these languages and use JavaScript, it was a huge mental shift going back and forth. So they kind of quietly settled down on the imperative style of programming on both sides. And that's one of the reasons why a lot of programmers using JavaScript still use imperative style, not because JavaScript didn't have a functional style, it's because of the comfort level we had in other languages, so we could use this too. But the ubiquity of the language is one of the things that fascinates me. We could run this on the server side, we could run this on the client side. I program in about, I'm going to say 12 different languages. I really don't care about programming languages. That's why I talk about them a lot. And I want to switch between languages like I change my clothes. And I don't mind doing that at all. I don't want to be branded as a particular language programmer because I just want to be a programmer, not a Java programmer or a C# programmer or even a JavaScript programmer for that matter. But one of the things that really excites me about JavaScript is the availability of this absolutely anywhere you can go. My fascination kind of keeps changing over time, but a few years ago, I can't remember now, maybe 7 years ago, I wanted to really build a very small application as a test server. I didn't have any much need for this. And all I wanted was just a server that would receive a HTTP request, do some little work, and spit out a fake set of data. And I know exactly how to build this in Java, and heck, I'm not going to do this in Java. That's a lot of work. I know fairly well how to use Grails and Rails, and Grails and Rails I consider to be very lightweight tools. But for the job that I had at hand, it occurred to me that Rails and Grails actually are heavyweight for that particular reason. It's funny how the word heavyweight and lightweight can be very relative to what we do. I did not know Node at the time, and I said, gosh, everybody keeps telling me this is easy to do in Node. So I actually picked up and learned Node in about 30 minutes, and I wrote this little thing that I wanted to deploy in Node, and it ended up being about 20 lines of code. And that's been in production for this about 7 years now. And occasionally I would log onto the server, and I would go there to that directory, and I would see that and take a minute and pause in a minute and say, I remember you that back in time. And that's one of the things I really like about it, is to really be able to put something out of value in a very little effort. Even though I didn't know a whole lot about it, it was easy to really adapt to it very quickly and use it. That's one of the things I really like about it. So of course, because of the functional style, we could use closures, we could use lambdas, we could use higher order functions. And of course, it's a language that provides prototypal inheritance rather than a traditional inheritance. I'll touch upon this later on in the talk, but enough talking, let's get down to some coding and have some fun. So I want to talk about some ground rules to begin with. Well, first of all, semicolon is optional, but it really is not optional. It's optional, like I will hurt you if you don't use it kind of optional. So it's something that could be really harmful if we're not careful about how we use it. So let's take a look at one little example and see how this matters. So I'm going to create a function called foo. Well, in programming, we always have something called foo. So I checked off that list over here. And I'm going to say, in this case, this is taking a number, let's say n. I want to say that if n is, let's say greater than 5, I want to simply return the value of n. Well, what if it is not? I'm going to say, in this case, else. I'll simply say return, let's say n times 2. Well, in this case, of course, I'm going to call foo with the value of 6. And as you would expect, the result was 6, no doubt about it. So I sent in a 6, 6 is greater than 5, so it returned the value of 6 itself. But on the other hand, if I say foo again, 3. Well, 3 clearly is not greater than 5, so what should it do? Oh, it should return a 6 as well, after all, but not quite exactly. So what just happened here? Well, remember, we did not put a semicolon at the end of this line, and JavaScript says, oh, did you notice you didn't put a semicolon? Let me do you a favor, and it puts one for you. So JavaScript is a very kind language, as you can see. So, but on the other hand, if you wrote this code as n over here times *2 right there, the behavior is very different. So what in the world is going on? So there is a bit of a logic that JavaScript uses. I know what you're thinking. You're thinking, did he just use the word logic and JavaScript on the same sentence? I know that's not usually the right thing to do. But it does have certain logic it uses. And the logic it uses in this case is it says, can the next line be a standalone line? And it turns out this can be standalone for whatever purpose it is. So JavaScript says, because it can be standalone, I'm going to put a semicolon. On the other hand, if you put a n times star, JavaScript says, it doesn't make sense for *2 to stand alone, so I will not put a semicolon right here. And that's kind of a silly reason, but that's what it goes through, or similar to something like that. So the moral of the story is two things. Don't be so callous about semicolons. We have to be very careful about where we put semicolons for sure, but also it's a good idea to make sure the code is actually doing what it's supposed to do. I know you have been through this problem as much as I've done before. The code never seems to type what we intend or do what we intend. It seems to do what we type. And in the case of JavaScript, that's very true. So we got to take the time to make sure we really are typing something and the code is doing what we really meant. Please.
So what if we have a minus or plus instead of a star?
So in this case, if you had a plus 2 like this, and then of course you're saying if you had an n and then n over here and then plus 2 like this. Well, in this case, of course, it's n plus 2, which is what? 3 plus 2 is 5. So in this case, again, it says plus 2 doesn't stand alone because this is not a valid expression to stand alone itself. You could use this in other parts of expressions, but as a separate standalone, according to JavaScript, that doesn't make sense to stand alone, so it doesn't use that. What if I had said minus 2 just for the sake of looking at it? So in this case also, it decided to kind of look at it and say, I'm going to put that together. So again, you want to really make sure that the code is doing what you really meant. Okay, so given this, we got to be careful about semicolons. But what about defining variables? Well, to define variables, of course, we can go back and say foo equals, again, a function. And then in this case, I'm going to say local1 equals, let's say 2. And I want to print the value of local1. Well, clearly I want to call the function foo right here, and we can see that it printed the value 2. But what if I printed local1 right here? We get an error. Well, that's a good news because local1 is local to that function, not available outside of this function, so that makes good sense. But on the other hand, if I were to say local2 equals 7, and then of course I'm going to print out local2. In this case, as you can see, it did print the value of 7. However, what if I were to print local2 right here? Well, JavaScript looks at this code and says, gosh, did you notice Venkat forgot to put var in front of the variable? What can I do to hurt him the most? So it realizes the worst thing it can actually do is to make a variable global. So it says, this is interesting, I'm going to make it global, which is a disaster, as you can see right here. In fact, if you really want to have some fun with people, here's something I suggest, but don't do this on projects you care about. So you call a function f1 here, but you say for I equal to 0, and then you say I less than 10 I plus plus, and then you say, in this case, call the function f1. But what does f1 do? Well, f1 is going to be a function right here. And what function f1 does is it says for I equal to 0, and then I less than 10 I plus plus, and I'm going to say over here, aha. And I'm going to call foo. I'm not going to run this code because I'm too fearful to run it. But the point really is, don't even bother asking me what does this code do, because I'm not smart enough to think about this on a given daily basis. The only thing I know about this code is don't do this. And the point really is, this is a variable I which is global, which means when you come in here, I is 0, and then you come in here and call f1, you are enjoying the same variable I at this point. So depending on the sequence of how things work, you can put this potential in an infinite loop, or it could die too early. So depending on, I mean, again, like I said, I have to stare at this for a few minutes to figure out, but there's an easy answer to this: don't do this. So what's the moral of the story? Well, the moral of the story is we could use things like something like option, use option strict. So we could say use strict, and things like use strict can help us to identify variables that we are not really defining before its use. That's one thing we could do. But there is a better answer than that, and that is quit using var. And rather than using var, it's a lot better to use let. There are two reasons why let is better than the var. Well, the first thing is, of course, you want to make sure you define variables before you use them. And var, is something that you can, define to make it local. What if you don't? Use strict can help you to find that. But there's one other problem we have to deal with. And that is if you were to define, let's say, a foo over here. And in this case, of course, I'm going to say, let's say local 1, I want to print it. But local 1, I'm going to say is going to be, let's say I define a variable local 1 equals 4. And of course, I'm able to print that variable, as we can see right here. But what if I were to define a block over here? And I say var local 2 equals 7. And I'm going to define and print local 2. But unfortunately, though, well, because I used var, good news, I cannot use local 2 outside here. That's a really good thing, no doubt about it. But I'm still within the function. And now I'm going to say local 2, and you can see that I'm able to access it. And the reason is var does not have a block scope. In other words, what JavaScript did right here is it happily walked around, came to this little curly and said, nice curly, and throws it away and walks over. So in this case, this is equivalent to local 2 equals 7 being assigned over here, and var local 2 being initialized to nothing up here. So in other words, this variable local 2 has been hoisted to the beginning of the function. And as a result, there's no block scope. We can avoid these issues by simply not using var, but using let. There are two benefits that let offers. The first benefit is let has a block scope. So as you can see in this example, I'm able to use let, and I'm able to print the value of local 1 and local 2. But if I try to access local 2 outside of the block, I get an error because local 2 dies as soon as I leave this little block. So let has a block scope. Another benefit of let is, unlike var, you cannot redefine a variable that has been defined using let. So if I say local 2 equals 7 again, you can see that I get an error right here because I cannot redefine a variable that has been defined using let within the same scope that is. That is another safety net you get out of using let is it avoids redefinition in the same scope. And of course, it also has a block scope that's a lot better. Well, there is also another thing called const I would encourage you to use. A const is a variable that is not allowed to change once you define the value. So my recommendation moving forward in JavaScript ES6 is, as much as possible, use const, and the times when you cannot use a const, then use a let. That's a lot better than using var, so I would remove var from my vocabulary and quit using it. Now obviously, one of the reasons we may say is, gosh, if it's so true, why didn't they remove it? Well, unfortunately, backward compatibility. A lot of JavaScript is out there, and they don't want all of that to break all of a sudden, so the engines have to still support old code. So var is going to be there for a long time, but moving forward in our own vocabulary, we can quit using that and then start using let and const. That's a lot better way to deal with that. Well, what about writing functions? Well, to write functions, I'm going to show you 2.5 different ways to write this. Well, the very first way you could write a function is probably the most traditional way you've seen people write it. I could say function foo over here, and then I'm going to simply say foo called, and then of course I'm going to just call the function foo. And you can clearly see that we call the function foo. But on the other hand, I'm going to go ahead and repeat this, but this time I'll go ahead and say foo redefined called. Well, the question here is, I'm going to run this code. What's going to be the output? Well, if we just parse through and eyeball this code, we would say here it should call the foo called, and then we redefined it, and it should call the foo redefined called. But JavaScript thinks the other way. It actually calls the foo redefined in both cases. Now, why is that? The reason is this function foo is actually hoisted to the very top of this. So JavaScript actually goes through one parsing and determines, oh, look, we have a function called foo here. So this function definition becomes the definition for foo. So when you call this over here, it actually uses that definition that's sitting right here. Well, that could be a little confusing sometimes. A better answer is not to redefine functions, but the language, of course, doesn't prevent you from doing it. What? Yes, please.
Just out of interest, can you always rely on the order, though?
Can you rely on the order, you're saying? No, you cannot. Yeah, you cannot, unfortunately. So that's one of the confusions we need to deal with. Hoisting is a good thing, but not always. As in this case, it doesn't play really well at all. A different way to write. Yes, please.
What's the motivation behind hoisting?
The main reason is the scoping of variables are pretty important. And the file scope versus the function scope is the default. It kind of goes back to traditionally how languages were done back in the 90s. One of the languages that really kind of made it popular to define variables under the local scope was C++. The concept has been around before that, but many languages didn't follow it. I remember very clearly back in the late 80s, C++, there was a aha moment. Wow, you could define a variable right here, and then it is available only from the point of definition. But a lot of languages never did that. The languages traditionally hoisted in the top of functions. Function scoping was the default in a lot of languages. JavaScript just inherited that kind of feature. It never gave the local scoping. That's where the hoisting comes from. So it's more of a tradition than anything else, because that's the way languages were back then a few decades ago. More modern languages do things differently, and JavaScript is adopting that with let, but that's more of an after fact than in the traditional sense. So it's more of a historic than anything else. And in this case, of course, foo, another way to do this would be to say let foo, or even better, const foo is equal to function. Now, obviously, if you said let, you can redefine it right here. So you could say over here, foo is equal to function, and you can redefine the function at this point. So you can see the difference in behavior at this point. You define the variable called foo on line number 1. That variable is still available from the top, but you just reassign to that variable in the line number 7, and then you're using the redefined variable, which is a reference or a pointer to a function. Now, what I would really like to do is to use a constant rather than that. Because if you define it as a constant, line number 7 is going to give you an error, as you can see. You cannot redefine the variable foo at this point because you defined it as a constant. So that's another thing to consider, is to use a constant. But of course, if you're using ES6, people traditionally use the function like the first way we saw. And I did mention 2.5 different ways of defining it. Well, some people like to define the functions as like this, but also put the name right here too. These people work for the Department of Redundancy. And you're trying to put this in 2 places. There are very few benefits to do this. One benefit is when you're calling recursively, you have a guarantee which foo you're actually calling if you define this. In this case, if you call foo here, it'll bind to this one rather than to that one. That's a small different advantage. The other advantage is maybe you'll get a better reporting on your call stack when you have errors. In my opinion, those advantages are pretty minimum compared to the trouble we take. And if I really want to be writing code which is tricky based on how I define it and where I define it, I usually frown upon that kind of coding practices. I want the code to be very clear and intuitive and less fallible, so I would rather not do that in general. So I generally prefer the const approach, but your mileage may vary. So you could use some of these approaches. Let's talk about arguments. Well, just want to quickly note that while arguments are available, I would encourage not using arguments moving into ES6. Thankfully, there's a better way to do this. But arguments are something useful to understand. So let's take a look at a real quick example. I'm going to write a function called max, let's say A and B. And in this case, I'm going to say if A is greater than B, I want to return A, and otherwise, I'm going to return, let's say, B. Let's go ahead and call max with 1 and 2. Well, clearly 2 comes out winning. Let's call max again this time, but in here I'll pass, let's say, 3 and 1. Well, clearly 3 came out winning too. But on the other hand, if I said max here with, let's say, 2, 7, 3, what does JavaScript do? Well, JavaScript is so smart. It said 7. Oh my gosh, this is awesome. How does it do it? Well, what actually happened in this case was you passed 3 arguments to a function wherein there is only 2 parameters given here. JavaScript kind of treats you like a guest in its house. I mean, if a guest comes to your house and they put the bottle in the wrong place, you don't tell them, you're an idiot, don't put it here, right? You kind of smile at them and say, these people are idiots. You think about it and move it around to where it should be. That's exactly what JavaScript is. It wouldn't really mind what you do. It's very tolerant to you. But in this case, what really happened is a very fundamental difference in the language. If you are used to languages like Java and C++ and C#, in a lot of these languages, even language like Ruby, for example, almost every other language we program in normally on a regular practice, the number of arguments a function can take is defined by the definition of the function. Not so in JavaScript. In JavaScript, functions don't define the number of arguments. The caller decides the number of arguments. So in other words, what is so esoteric and special in a lot of languages is the normal thing in JavaScript. In JavaScript, every single function is a var arg. So every single function takes very number of arguments in JavaScript, which is pretty cool actually, because giving names to variables is just an optional thing you can do. So in this case, for example, you just gave variable names A and B, but that just so happens that you named the 2 arguments, but there could be a lot of other arguments you just never care to name. So to understand this, let's go back here and simply output arguments over here. Notice when you run this, you can see the arguments being given to each one of these functions. So in fact, it really doesn't matter whether you named these arguments or not, because it doesn't care about those things. Arguments are the ones that really represent arguments in JavaScript. So in this case, of course, now that you have these arguments, what you could do is you could say, let's say result is equal to arguments of 0, for example. Then you could say for, and we could start with I equal to 0, and then I less than arguments dot length. And then, of course, you can take I++, and then you would say, for example, if result is less than arguments of I could say result is equal to arguments of I. And then finally, of course, return the result from this. So this becomes a variable number of arguments you can use. In this case, of course, if I say 2, 8, 9, and 20, you can see that it actually gave us the right result of 20, whereas previously we were only considering the first two, A and B. Well, the point really here is arguments actually rules. Now, having said that though, I would recommend not using arguments moving forward. And the reason I would recommend not using it is, when you look at this code, it's not obvious at all. You can't look at this code and say how many arguments it actually receives. It could be receiving nothing, or it could be receiving a lot of arguments. You want a code that is easier to understand, easier to express. That's one problem. The second problem is, what kind of object is arguments? That's a very sad story. Arguments is not a vector or an array, it is an array wannabe. So it doesn't behave like array, it kind of pretends, and the moment comes when you want it to be an array, it fails you really bad, which is really, really problematic. Because I really like to write functional style code. I cannot use functional style code so easily in this example, because if I go to arguments and I call methods like filter and map and reduce, it'll look at me and say, what are you talking about, right? And it's a really let down when it doesn't do those things. If it was an array, I could use those functions really nicely. So what's the answer? The answer is to use the rest arguments moving forward. So you can say, for example, values, and values becomes an array that you can actually use. So in this case, if we just print out the values that is being given to us, you can see those actually are arrays and not the object we saw a few minutes ago. What that means is we can do something really nice like this. We can say return, for example, values dot, and we could say reduce, and we could start with a value A and B, and then we could even use an arrow function and say, if A is less than B, well then return B, otherwise return A, and you could be writing code like this. Now keep in mind, you have to deal with values being empty. Reduce could really bomb on you if you're not careful. I'm not doing full error checking right now, but the point is I can write very concise code like this when it is a noble object like an array. Arguments was really a letdown. That's one problem. The other problem is they really messed up with lexical scoping when it comes to arrow functions. And arguments don't work very well with arrow functions. In fact, in arrow functions, if you use arguments, it would actually pull the wrong arguments, not the one you really meant to. So general recommendation is know about arguments, but have the wisdom to not use it. I don't think there's any arguments about it anymore. So the point really is that it's better to use the rest parameters rather than using arguments. But arguments are a very powerful concept. They just evolved to something a little bit better. The other thing to be careful is this. And I really like the power that JavaScript provides for you. Well, in a traditional object-oriented language, when you create a class, you normally create objects of a class that you create. And then the functions of the class are owned by the class, and then you get to use it. Well, in the case of JavaScript, you can nicely walk along and say, hey, looks like a nice marker, I want to use it. So you can just acquire functions as if they are methods. So here is an example of this. Let's say greet equals, and I'm going to say here is a name that I'm going to pass to this. And within this, I'm going to output, let's say, hello, and then I'm going to say name right here. Well, in this case, of course, I'm going to call greet and say Jane right here. So if you notice here, it says hello Jane, which is pretty good. But I can also do the following. I can come down here and say, well, what about this dot to uppercase and then call the rest of the method? Well, but suddenly I use the word this. Well, this is a normal function. It's a global function. But within the global function, I am calling something called a this. This is a context object. And you can attach context objects to functions very nicely. So what I can do here in this case is, I can call greet with a call, and the first argument you pass to call is the context object. The second argument you pass is actually the first parameter. So in this case, the hello became the context value that you're able to pass along to this particular function very nicely. So this is one way for you to, so to say, acquire functions but run in your own context. For example, I could call greet now, and I could say howdy, comma, Jane right now. And in this case, of course, you can see that it says howdy, Jane, because this has been reassigned to a different context. So this becomes a context object. This is also a source of pain quite a bit in Java, because you may pass a function to some other object, and that might be calling your function, but the this it calls gets reassigned to something you probably didn't expect at that point. And I've spent a lot of time debugging code when it was caused my own fault, not thinking clearly about what this is assigned to. This is one of the reasons why people often write code like self equal to this and use self, or even more better, they use this, that equal to this and use that, and that kind of becomes very annoying. That's one of the things they fixed again when it comes to arrow functions. Arrow functions don't have any more this. The this within arrow functions have lexical binding to the this of where the arrow function is defined, and so that's no longer available like in this context, which is kind of bizarre if you really think about it, because this is a broken model if you really think about it. In the case of a function, if you think about a function has lexical scoping for all variables except this an argument. And that just blows my mind, because that's kind of stupid. Because one thing you want to be is be consistent. And JavaScript is consistently inconsistent. And that is one of the biggest challenges with it. So in a regular function, while a lot of variables you use have lexical scoping, the this and arguments don't. In the case of arrow function, everything now has lexical scoping, so they made it consistent now with arrow functions, and that also removes a lot of annoyance we get into with the this that normally happens. But then what about the apply method? Let's quickly pay attention to that real quick here. So I'm going to say name1 and name2, and I'll say name1 and then plus, let's go ahead and say here a comma, and then of course we'll say plus name2. So I got two names I'm going to pass. Well, how do I call this one? Well, clearly you could have said a call over here, and then you could have said hello, and then of course you could say, Jack and Jill. So this works really well. And of course you called hello Jack and Jill. However, what if I already have a variable with me? So let's say constant names equals, let's say we have Tom and Jerry, and I want to call this with greet.call, and I'm going to say hi, comma. Well, you could say names square bracket 0, comma, names square bracket 1, which is kind of a little silly. You could do this, nothing wrong with it, but there's got to be a better way to do this. Well, there are two better ways to do this. In traditional JavaScript, you could use the so-called apply function. So what does apply do? Apply will take an array, and it will then spread the array across to these parameters. So traditionally in JavaScript, you could use apply. I would encourage you not to use apply moving forward again. There's a much better news for apply. What you can do instead is you could say, call, using this, and then I'm going to say hi, comma, and I'm going to say names right here, and the spread argument works really well. Well, wait a minute, I used triple dot, but I said it's a rest a few minutes ago. It's a rest argument when used in a declaration. The same operator is a spread argument when you use the argument when you make the call. So this will take the array and spread it across to different variables. So the reason to use apply has kind of diminished over time. With ES6, I don't see a reason to use apply. I would rather use a spread argument, a spread operator, to get the same result, if you will. But these concepts are very important to keep in mind, because a lot of different libraries have been written to save JavaScript programmers from these kinds of details and mess. But knowing gives us a really good control with JavaScript when we use it. But I want to shift gears and talk about, please, yes, please. Yep.
Would you use that pattern of setting this context to changing the way the function behaves in production code, or is it
Oh, yeah, I do use it in production code very carefully, though. There are times when you don't have a choice, really. For example, I want to register an event with a button, for example, or I want to register an event with a timer. And when it calls back into my code, I want to be able to access my properties in my function. And so the context object is something I cannot do away with. It becomes a very instrumental part in the code I write, because let's say I want to do a work, but I want to register with your object, and you are going to be making a callback on me. When you make a callback, my function says, oh, thanks for calling, but I want to go get my property from my object. But where is the property now? Well, this becomes a property to access. But unfortunately, when you make the call, if you bind this to a different variable or an object, then when I go to that object and ask for the property, I'm going to get an undefined, or even worse, I get a wrong value which happens to be coincidentally part of that object, and that's a mess we have to deal with. But unfortunately, we cannot get away by ignoring that. We definitely need it. So this is when a lot of times, you set a local variable for lexical scoping, and then you call that local variable instead of using this, and you have to deal with that constantly. So you have to use that quite often when you do callbacks and register with things. If you're not using callbacks, this is one of the reasons why I like promises, because promises removes that burden on you. You can get the response back, and you can deal with it on your side, but we don't have the luxury of doing that all the time. So anytime you're using callbacks, this could be an issue that you have to deal with. Arrow functions definitely avoids that problem to a great degree, but unfortunately, if you're using traditional JavaScript, when you don't have arrow functions, you still have to deal with the mess constantly. Yep.
Do you think it's valid to use bind then?
The bind is also going to use this, and definitely bind is a good thing to do. For example, let's say I have a function called greet, and in this case, I want to say, call this back a little later. So I'm going to say function. Let's just give a name right here for an example. So in this case, let's say, I'm going to just say hello, name itself. Well, let's say set timeout, and in this case, I want to call this after a second. So, but what am I going to do? I'm going to write a silly code like this. I'm going to say function, and then I will say in here, greet, and then I will call with, let's say, Joe. So in this case, when I run it, a second later, it says hello, Joe. But that's a lot of noise in the code. But the point is, set timeout is not going to send me any data or parameters. It doesn't care about it. Well, one of the nice things about this is I can say greet.bind, and then null, which is kind of silly because I don't have this to bind at this point. Then I could say Joe right here. So these two are actually, let me actually leave the other code also so it's easier to see the relationship between these two. So in literally what's happening at this point is, if I were to say greet.bind right now, and then I say Joe, then I can take the result of that and I can nicely pass it into this function right here. So when I run this right here, you can see that in this case, null, of course, I was mentioning that. So you need to pass that. So what bind is doing is, it literally does kind of like what this function is doing. So it's creating a function which will then take this argument and bind it to this function. So it's kind of like, if you want to really call this as, bind to me in JavaScript is kind of like currying. That's what it's really doing. It's currying this argument to that particular argument so that you can use this curried function. So bind is really a curry function in JavaScript. They just didn't call it curry, they just called it bind. The silly thing I don't like about bind is the fact that it actually requires this to be passed in. So a lot of times we put a null if we don't care about a context object. But if we do want to pass a context object, you can just pass what you get from there. So bind is definitely still a pretty significant thing to do. When still you're using callbacks, it can be a powerful thing to do, absolutely. Yeah. So talking about higher order functions. This is something I'm trying to do a lot more moving forward, is to move more towards higher order functions than traditional functions. For example, let's say we have numbers is equal to, and I'm going to call this as a bunch of numbers I want to start with. But I want to say a total of double of even numbers. So how do I total the double of even numbers? We could say let result is equal to 0, and I want to print the result when I'm done with this. But what is the code going to do in this case? Well, we could say for, we could say let I equal to 0, I less than numbers, I plus plus, and then we could say something like if numbers of I mod 2 is equal to 0, well then of course result is equal to numbers of I times 2. So this is plus equal to, and then we could do something along these lines to go through it. Well, I equal to, this is dot length, isn't it? So dot length. So quite an effort to do this. Well, there are a couple of different options available to us. This is one way to do it. A slightly better way in ES6 is to say let result is equal to 0, and once again of course I want to just print the result when I'm done. But we could say for, and we could say constant element of numbers, and then we could say if element mod 2 is equal to 0, then result plus equal to element times 2. So we could use a shorter syntax of the iterator with the of. So this becomes a nice way to iterate. Still, I'm not happy with this because this is still an imperative style of programming. But what I could do instead of this is we could say, well, given numbers, so we could start with the given numbers, and we could use a filter. And in this case, we could simply say, given the filter, we could say function given an element, we could say return element mod 2 is equal to 0, and this becomes a filter operation, followed by, we could say dot map, again given a function with the element, we could return element times 2 from this, and we could of course put this into one line, just a little bit easier to see this. And then of course we could do a dot reduce, and in this case of course given a total comma element, we could take this one and say total plus element. So we could say return total plus element. And in this case of course we could use this style of taking the values, so reduce function, there we go, and so return, there we go, and that gives us the result. A little noisy, but still a functional style of code to write. Well, this is where the arrow functions really shine. What we could do now is we could simply say this becomes element and then arrow element, so we could reduce the noise quite a bit. So the arrow functions reduce these kinds of noise of the word function and return. If the body of your function is a single line, I would use an arrow function. If the body of your function is multi-line, I would like to keep it as a separate function, at least define it outside and not inside of this, because the cuteness and the power of arrow functions becomes low if you try to put multiple lines on it. So similarly, we could take this and say, given an element, I want to simply return element times 2, and then finally, of course, this becomes given total comma element, we can simply return from this one the total plus element, and we can write it a lot more concisely. So the functional style of code is where my heart is these days, not because it's fancy, it's because it eliminates accidental complexity in code. When you're writing code, you're doing a lot of garbage variables and actions that you normally do when you write imperative code. A lot of those things disappear when you write functional style code, and this is one of the reasons why they went on to provide the arrow functions, because it actually makes the functional style code a lot more approachable, concise, and expressive, so definitely in the right direction. Please.
Don't you think that the style of the bottom version is much harder to debug than the imperative?
So the question was, isn't the code in the bottom much harder to debug than the one in the top? I don't spend my time writing bugs, so I don't know, just kidding. So, well, it could be, it depends on the tooling for one thing. But not only depends on the tooling, in general though, if this function is very complex, you don't want to really use a arrow function here anyways. And I rely on, so in all honesty, in my youth, I used to spend a lot of time debugging. I would literally leave work, and when I come back the next morning, the cursor will be blinking where I left debugging with pizza on the keyboard. I got too tired and I left in the middle of eating and coding. I don't debug that much anymore, honestly. I've truly adopted a lot more test-driven, automated testing approach. And I'm not going to say I don't debug at all. That would be a lie if I say that. But a lot of times my debugging these days is, oh gosh, I don't understand why this test doesn't work. I'm going to put a breakpoint in the test. And usually I step in 2 lines. I'm like, duh, of course I know what I did wrong. I'm stupid. And I fix it right away. So the amount of time I spend debugging is a lot less today compared to a few decades ago. Mainly because, I've kind of grown a little bit better. But also I've adopted better programming practices as well, writing shorter methods, more meaningful variable names, more automated tests around my code. So I would rather compensate with better practices and avoid having to debug excessive code than the other way around, where the code is complex, which in turn I have to debug a lot more. And the second thing is, one of the things we follow in functional style code is, a lot of these functions have to be pure functions. Unfortunately, JavaScript doesn't guarantee that for you. We have to make sure it's pure function. But the nice thing about pure functions don't have side effects. So testing those functions usually is a lot more easier and simpler than testing imperative style code as well. So overall, much less need for debugging, and so that kind of compensates for that quite a bit.
Actually, it might be a bug in the code.
It might be a bug in the code. What is the error in this code?
I think it's undefined.
The result is undefined, you're saying, in this case. It did give us a 24. But yeah, there could be other issues you have to.
Initialization of reduce, I think.
Oh, numbers could be undefined. Oh yeah, you're right. Yeah, absolutely. None of these examples don't take it literally and put in production. You have to always write code to deal with those situations. That's one of the things I'm not a big fan of reduce, is what if the collection is empty? So you have to handle that, unfortunately. Well, but the good news is, this is one of the reasons why you give an argument in the beginning. That can help you to say, well, if the collection is empty, what do you want to do with it? So you can always work around it fairly easily. It's not that it's too hard to work through it, but usually, I kind of take a test-driven approach. I don't write code anymore without having a failing test. Then I write a minimum code to make the test to pass. So usually I kind of let my test drive my code than thinking too deeply. I'm a big fan of not thinking, right? Then I can think about more fun things to think about than worrying how the code is broken. So I kind of let the test to drive it and deal with it. So it looks like that's kind of broken as well, but you get the point. Okay, so let's talk about equality. Well, this is a big mess. We got to be really careful about this. So let's say constant a equals, let's say 1.0. Well, let's say 1. And I'm going to say constant b equals 1, and then constant c equals 1.0. Now, let's say a equals b. And it says, sure. This is the part I would ask you to cover the eyes of the child, because they lose faith in humanity when you show this. All our decades of development goes away. I usually am very fearful when a child is in the audience, because this is the part you got to be very careful about, because they're going to go home and say, is this really true? I have 2 sons, by the way. I'll tell you this. I got 2 boys, and they looked at what I do, and they came to me one day and said, Dad, this stops with you in our family. So I'm here to tell you that I am the last programmer in my family. Next of my hereditary descendants, there's not going to be any programmers until at least a few generations later, and I'm responsible for that. Because my kids walked in, sat on my lap when I was coding, and then when they got a little mature, they looked at me and said, this is what you do for a living? That's it, I'm not going to do this. So I lost programmers that way, but so be careful. So b equal to c, it says true. Now, logically speaking, you may argue, if a is equal to b and b equal to c, then a should be equal to c. And JavaScript says no. So this is like, gosh, why not? Well, the reason is the double equals, unfortunately, is not a comparison. The double equals is actually convert and compare. So if the objects on both sides are not the same type, it applies conversions before it makes this comparison. And I'm going to say most JavaScript out there including my own, is broken. Because the more we use double equals, the more trouble we are in. And the chances are we really meant comparison without conversion. And that's a 3 equals rather than 2 equals. So traditionally, the 3 equals is for comparison. The 2 equals is actually convert and compare. Unless you really meant it, we shouldn't be using it. Likewise, if you want to perform a not comparison, you don't want to use a bang equals, because in this case, again, you can see it's inconsistent. What you really want to use instead of that is a bang equal, and that way it'll be consistent for all of those. So the moral of the story is triple equals instead of equal, and bang equal instead of the bang equals is most likely the better solution to use. Which is kind of strange, because moving forward, one language that did this fairly well is CoffeeScript. So in CoffeeScript, when you use double equals, it actually means triple equals. So they kind of got rid of the double equals in CoffeeScript. So when I looked at TypeScript, I was a little eager to find out what TypeScript does. Unfortunately, because TypeScript wants to be a superscript of JavaScript, the double equals is still a double equals. Unfortunately, I really wish they had converted to a triple equals under the hood, but that's the way it is. So that's going to stay with us for a while, whether using TypeScript or JavaScript. Consider using 3 equals instead of 2 equals, unless you really mean conversion, which rarely is the case. Functions are objects too. What can we do normally on objects? We can call methods on it. Same way you can call methods on functions. In fact, we already did. We called the call method and the apply method and the bind method. All of those were called on function. So functions are objects too in JavaScript. But how do we go about creating a class? Well, I'm going to talk about the traditional way right now, not the ES6. Well, in the traditional way, what you do is, if you want to create a class, you could say, for example, function, and then this is going to be, let's say, car equals function, and then you could say created. So what we just did here is we created a class called car. You say, wait, we created a function called car. No, we created a class called car. Well, how do you tell? Notice the uppercase over here. Well, that is the convention of JavaScript. So the convention in JavaScript is, if you decided to use an uppercase, your intention was to use the function as a constructor. On the other hand, if you defined it with a lowercase, your intention was to use it as a regular function. So you kind of have to know what your intention was. So in this case, of course, I'm going to say that new car and create an object of this. So we'll say car1 equals new car, and I'm going to say car1. Well, it did say created, and it gave us this little object. But what does it really mean when you create using a new? It would be really nice to understand that. So I want to talk a little bit about how this actually manifests itself and what does it really mean. Well, to understand this, let's go ahead and say year, and I say this dot year equals year. So in this case, I say 2017 and call it, and you can see that it says car and then year, please.
Yeah, I have a question. Is the way JavaScript treats classes versus functions really in the type of the definitions, or so in here in the example line 1, or is it just the usage of I use the keyword new to
That's right.
create a class? So if I write a variable car in lowercase and just use car in a lowercase version?
Right. So this is only a convention. JavaScript doesn't know and doesn't care about it. It's for us. So the question was, is it new that really makes the difference, or is it the convention? Assume that's the question. And the answer is, it's a convention for us humans to kind of comprehend what this is. But the real key here is the new. If you had used a new, you would have a target, a constructor being set under the hood. If you don't use a new, you don't have a target given to you. So the behavior changes whether you use a new or not. Now clearly, if a function was not intended to be a constructor and you used it as a constructor, really bad things could happen at runtime. but JavaScript doesn't care about it. So it really comes to the new keyword being used here that decides the behavior of this code. In this example, though, you can see that it contains the year 2017 being set, but what's really happening at this point? I want to say there are 3 steps that happen at this point, logically speaking, that is. The first step here is allocate memory for the instance. So we call it inst. So that's the very first thing that happens. It allocates memory for the instance. How can I tell? I want to output this right here, and notice the first line. It's a curly with nothing in there, right? So that is the instance that got allocated. So that's the very first thing you see. It got allocated the space right there. The second thing that happens is that it then comes down and says, well, let's ask the question up here, output this dot proto. What is the prototype of this particular object? So you can see that's empty right now. Well, that's the second thing that's going to happen. It says instance.proto is equal to car.prototype. So it's going to assign the prototype of this object. The third thing that's going to happen at this point is it's going to say car.call and then the instance, comma, whatever the value is, 2017. So in other words, it's going to run the constructor function in the context of the current object that got instantiated. So in reality, when you create a new object in JavaScript, this is equivalent of what's happening. Memory gets allocated, the prototype of the object is initialized to the prototype of the function, and then the function is executed with this context in the context of that instance that got allocated the memory for. So in a sense, what the new does, going back to your question, is the new causes that function now to be executed in the context of that instance you just instantiated. Please.
So when we allocate the space, we don't really know how much space we need because we can't define properties. We just say this is that, and so it always dynamically just has to increase. So it's not like in other languages where you say okay, this object takes 100 bytes or whatever.
Right.
It just grows dynamically.
Well, so that's one of the cool things about JavaScript. This is true also in Ruby, for example. No two objects of the same class are required to have the same properties. So your object could have properties my object doesn't have. And that's perfectly okay. That's kind of the true word dynamic comes to shine in this case. This is true in Ruby as well, by the way. In language like Ruby, you can take two objects of the same class, and then you look at the properties, they're not the same, the fields, they're not the same. But to be in all fairness, this is true if you have an array or a list as well, for example. So in Java, for example, or C#, if I have an array or a list, I quite don't know how much I'm going to need. All I'm creating is a reference or a pointer, and then behind that it could be growing and shrinking. And that's usually not a problem. It can grow and shrink dynamically based on the need. In this case, of course, these are just pointers that get added to this object, and the runtime can take care of that for you. Yeah, but you're absolutely right. That's one of the beautiful things is tomorrow you can come and add yet another property to this, just to one or two objects. In a way, I would argue that's more efficient in memory, because if I create 1,000 objects, whether I care about it or not, all the 1,000 objects have exactly the same properties, whereas here, hey, I can load up properties I want, and 999 of my objects may not have one property, but this one is going to have it, which is a better use of the memory as well.
But
so
then they always have to go on the heap.
But
not the case in Java, for
in Java also, objects are always on the heap.
Okay.
Yeah, unless it's C# has concept of value objects. Java yet doesn't have one. Eventually Java will have value objects, but we don't have that yet. But in this case, it's going to be on the heap, you're right. Yeah. Yeah. So given this, how do we benefit from this one? Well, we can have properties as you would look at it. So how do we work with properties? Well, here is a property. So I can say the following. I can go to the object of car, and then I can say in this case, output car1.year. But one of the things I really like about this is I can also say car1 a square bracket year. I really like this because I don't need to know what the name of a property is ahead of time. So this can make my code really dynamic. So I can take a variable name coming into my argument to my function. I can turn that variable name and access it as a property, which becomes really convenient to make this very dynamic. So you can access the properties if you know the name ahead of time using a dot, or you can put a square bracket and you can say something like a field name, where a field name could be something you enter at runtime. This could be being read from input someplace rather than predefined. You could do that as well very nicely. But that brings up the question about where these properties are. So to understand this, I'm going to skip this for a second. I'll come back to this. So if I go to the object, I mentioned slightly about prototypes. Well, let's go back and step a little further with this. Let's say we have Sam equals, and I'm going to say first, and we'll say Sam, and age is going to be, let's say, 2. And I'm going to print out Sam right there. So I'm going to call a method on this object. So I'm going to go ahead and write a method, let's say constant work with Sam and equal to function. And in this case, I'm going to take the object over here, instance, we'll just say work with, and I'll put a little try block, if you will, and then I'll put a catch, and within the catch, I will simply report a no such function. And here I will call instance.work. So to prove the point, if I were to call work with and pass Sam, you can see it says no such function because there's no work function on Sam. So that's great. But here comes the beauty. I could say, for example, constant employee equals, it's a little too early for Sam to become an employee, but nevertheless, I'm going to say this is a work method. And what is the job of Sam at this point? Well, we're going to say in this case, this is a child, so I'll change it to a child. So what is the job of a child? The job of a child is to play. So I'm going to say in this case, output will say simply play. So we're going to have Sam play when we call that little method. So let's see if that's true. So I'm going to say sam.proto is equal to child. And then I'm going to say work with and then pass Sam over to that method. And you can see suddenly it says play. So what just happened? This is one of the cool parts about this is Sam has a prototype called child. And the way JavaScript works is when you look for a property on an object, if the property doesn't exist, it quietly looks for the property in the prototype. It's kind of like you can come to me and say, hey, can you give me change for, let's say, 10 euros? Well, sure, I could open my wallet and give you change for 10 euros. But if you said, can you give me change for $10? I don't need to carry $10 with me at the moment, but I'm not going to say no. I'll reach into my bag and get you change for $10. So the point is, objects can look for stuff on their own, and if a property doesn't exist, they reach into their prototype. But this is where the prototypal inheritance really shines. Notice what I'll do now. Const employee equals, and I'm going to go ahead and write the work method. So what does the work method do? In this case, it's going to be working. So Sam eventually changes from a child to an employee. So in this case, I'm going to say employee and work with, and then I'm going to say Sam right now. Now what does this do? You can see it says working. I didn't change Sam. It's still exactly the same Sam, but the behavior is different because we changed the prototype. Well, imagine tomorrow you have yet another one called manager. And what does the manager do? Well, work, it says function, and we know exact behavior of this code, play golf. So Sam goes back to playing. What a wonderful circle of life. So work with again and pass Sam, but sam.proto equals manager again, and you can see it's exactly the same object, but it goes through transitions. This is one of the things I really like about JavaScript is I can do automated testing much more easily by marking out dependencies, by simply modifying prototypes of objects. So this kind of gives us an idea about the prototype, but that brings up the question, where are these properties located? But before we understand that idea, let's explore this a little bit further to understand how this actually works in reality. So, really, yes, please.
Can I attach another function called work to the instance itself and they coexist then?
Yeah, well then, so the question is, can I attach a work method to the instance itself? When you have a property on an object, it will get the property from the object and not go to the prototype. So yes, you can. So you can attach a property and say, use this one, and if you were to remove that property for any reason, it would go to the prototype and get it. So
to set it to undefined again.
And yeah, well, you would just delete it at that point. But on the reverse, what I like to normally do is, during automated testing, I might inject the method into an object. That way it doesn't go to the prototype to get it. It would get it from the local. That can be another nice way to test. And the beauty is, because this object is short-lived in my test, it's very safe to inject it and then play with it. And then when you delete the object, it quietly goes away and you're not affecting the rest of the system. So that could be, I mean, this is where I really started to enjoy JavaScript, is I turned the fear into power. And these concepts, which were really fearful, suddenly turned around to become tools, and I can leverage these to really do automated testing on these things. That's when the language became fun to work with rather than being fearful about the language. So absolutely, we could definitely do that. So you could delete objects' properties. I recommend not doing this too often. Delete will just get rid of the property from the object. You can just say delete and the property name and it goes away. You can have methods on the instance, you can have methods on the classes, and of course, when you have methods on the classes, they are shared by different instances. They depend on the prototype normally, and where you put them makes difference. But to understand this, let's go back and talk about this one more time. So let's say we have a constant car equals function, and in this case, I'm going to say, let's go ahead and say we have a function called drive that I'm going to create. So car.prototype.drive equals, let's do this, miles equals, let's say 0. So I've got a miles value of 0. Car.prototype.drive is equal to, let's say, a function right here. And in this case, of course, distance, and I'll simply say this.miles is plus equal to distance. What I want to do now is create an object car1 equals new car, and in this case, let's say 27. Well, actually, we don't care about the year. And I'll print car1.miles. And you can see the miles is 0. But before we go any further, keep in mind what happens at this point. Instance is allocated, which is this guy. Prototype is set. And then, of course, constructor is executed. Well, this happens on that line of code right here. Now, let's say constant car2 equals new car. Well, I'm going to ask, what is car2.miles? And clearly, that's 0. But I want to ask the question, is car1.prototype is equal to car2.prototype? What do you think is the answer at this point? It's a true, and the prototypes are exactly the same, right? So now I'm going to say car1.drive 10, and I'm going to say car1.miles, and it's a 10. But remember, the miles is on the prototype. So my question now is, I'm going to say car2.miles, and the question is, what would that be? Well, this is where the real smartness of JavaScript comes in. Let's understand this with a little example. What's really going on here? This is prototypal inheritance, and we need to really understand prototypal inheritance because ES6 is changing the way we write classes. Make no mistake, ES6 has not changed inheritance semantics. The semantics we're going to see here is exactly the same semantics in ES6. This is a syntax sugar. And if we're not mindful of this, we'll be surprised about the behavior. So to understand this, let's take a little example. Would you be my prototype if you're willing? He accepted eventually, so you're the proof. So here's my prototype. Well, let's say now, here's my prototype. I'm happy to have him as a prototype. He's comfortably sitting over there. Let's say he comes over to me and says, hey, Venkat, can I borrow a euro from you, please? You know what? It's not going to kill me.
Oh, I don't like where this is going.
So he says, can I borrow a euro from me? It's not going to kill me. I'm going to lend him a euro. There you go. He takes the euro, comes back in an hour and says, thank you for your timely help. That really helped me to, pay that little token in the parking lot. You're very kind. There's an alarm going off already. So,
Test alarm.
is it test alarm? Okay, all right.
First of everything.
Cool. All right. So, I just gave him a euro and look at the alarm going off already. He gives me back the euro. We have become trustworthy now, right? Hey, man is trusted. He took a euro from me. He got me a euro back. Well done. Well, a few days goes by. He comes to me and says, you know what? I desperately need 100 euros just now. Could you please give me 100 euros? We have built a trust between each other. So it's no problem. Except for one problem, I don't have 100 euros. So what am I going to do? Ask my prototype. So my prototype says,
Do you know about inheritance yet? Because I would ask my friend.
yeah, well, but that's your problem. So I'm going to ask my prototype. So what does he do? He gives me 100 euros, which I generously give to him. He takes away and comes back in a few hours and says, thanks again for your timely help. And he gives me the 100 euros. What do you think I should do with this 100 euros? I'm not listening to him. I'm asking your opinion. Keep it. I love that idea. So I'm going to keep the 100 euros. Does anyone have the problem with it? Except him, right? Well, if you understood what just happened, that's exactly what JavaScript does. In other words, in JavaScript, gets are deeper, sets are shallow. And this is one of the biggest plays of JavaScript. So what does that mean? Gets are deeper, sets are shallow. When you query for an object, if the object doesn't have the property, it goes to the prototype. If the prototype doesn't have the property, like you pointed out, it goes to the prototype, and then keeps going until you run out of prototypes. But if it was in the chain anywhere, you obtain that object. But on the other hand, when you set the object's property, it is on the top level, whatever this is. It doesn't say, oh, I didn't get it from me in the beginning, I'm going to go down. No, I'm going to keep it. So it's a shallow set, not a deep set. Let's understand if this is really true. Well, first of all, let's run the code. And from the code execution, you can see that the miles was actually 0 for the car 2, even though the prototypes are exactly the same. So what just went on? To understand this, let's rework this example just a little bit. So we have two objects of car, sure enough. Let's go over here and say for, let's say, constant prop of car 1. So we're going to ask for all the properties of car 1. And in this case, we want to ask for the car 1's properties and find out what it contains. So in the car 1, it's got miles and it's got drive. And that is the biggest lie, right? Why? Because a car 1 has neither one of them. So you come back to the car and say, really, dude? So you ask it, car 1 dot has own property, and then you're going to ask for the property on it. And notice it says false for both of those. The car doesn't have those two properties. It just pretends that it does. It's kind of like you come to me and say, how much money you have, Venkat? I'm very rich because I have a very rich prototype here, right? But how much money you really have? Not a whole lot. So the point really is the properties don't belong to this object. It actually might be in one of the prototypes. On the other hand, if I come here and say car1.drive10, and I've called the drive method right here, as you can see. But the minute I call the drive method, I'm going to ask the same exact question as we did a minute ago, and notice this time the answer is different. This time around, you can see it says the miles is true because the drive method set the value of miles. And because sets are shallow, the object now has a property called miles when it did not a few minutes ago. And on the same token, however, if we were to ask the car2 for miles, it would say it doesn't have it really because car2's mile has not been set. It's still in the prototype at this point. So this is basically the idea. But yes, please.
Could you also write this and then proto miles equals and then it's still in the prototype?
A little dangerous though. So if you say car1 proto and then miles, you will, well, in this case, of course, the prototype, let's see what level it is in. So, sorry. So, thank you. So that is still 0. But very careful, right? So actually good question, because this is one of the reasons why JavaScript really becomes hard to work with. When you are within the object, if you really want to go talk to your prototype, the syntax can become really ugly and burdensome. So the concept of prototypal inheritance is very powerful. But the syntax around the semantics has been really poor, and this has been one of the biggest deficiencies of JavaScript. So what ES6 did is it kept the semantics exactly the same, but it cleaned up the syntax really well. So this is a good news and a bad news. It's a good news, you got a lot better syntax. It's a bad news, they gave the syntax from Java. Well, Java's inheritance is class-based inheritance. JavaScript's inheritance is prototypal inheritance. We have to keep that constantly in our mind. I'm not a big fan of syntax sugars, because a syntax sugar should not mislead you into a different semantics. In the case of ES6, the syntax sugar is misleading. If I'm familiar with Java, I'm looking at these two. Both look like a dog, but one is a donkey. The other one is really a dog. In this case, I really like prototypal inheritance. I'm not a big fan of class-based inheritance. So this is actually superior in my opinion, but the syntax may be a little clouding that semantical difference in our head. We got to be a bit careful about it. So the methods are located by the dispatch mechanism, as we just saw, and goes and finds it. That's one of the beautiful things we saw. And that is the has-own property that we can use to find out where the property is. So just to talk about it now, a class car, and then you could, of course, in this case, create an object of car. So you could say constant car1 equals new car, and you could create an object of car using the syntax of JavaScript ES6. Now, in this case, if I had a vehicle, if you will, and I could then say, for example, extends vehicle, and I could use the extends keyword, but keep in mind, this is not our class-based inheritance. This is still prototypal inheritance. Thus, the result of this operation is, now car has a prototype, which is an object of vehicle, which is the base type. So it's a prototypal inheritance under the hood, not our class-based inheritance we are used to in other languages. A couple of small other details to finish up. One is arrays. Arrays are really weird. They really are, when you get a value as an array, the properties are indices in an array. So you got to be a bit careful about it. Deleting a property may leave holes in an array. You got to be careful about it as well. And of course, arguments are not even arrays, so you have to be even more careful about them. What about exception handling? Well, the JavaScript follows almost the same things as other languages like C# and Java do in terms of the try, catch, and finally, with a few little differences. So for example, if I have a function called some do work, and I'm going to call this with a value, some value n, and in this case, I could do a try, and I could call do work with, let's say, a value 5 of some sort. And then I could say over here catch, exception, and then I would say cut. And then finally, we could do a finally as well. And in this case, of course, we'll say in finally. So we could call these methods like this. Except for the type information, the syntax is very similar to what we do in Java and JavaScript. Java in C#, you just say try, catch, and finally. Well, a few other small differences. When it comes to here, you could say if n is less than 0, you could simply say throw. You gave a 0, I will come burn your village. So you could throw what kind of messages you want. You can throw just about anything you want to throw. Hey, wait a minute, in Java and C#, I got to create an object of exception if I want to throw. There is no such civility in JavaScript. You can throw anything you want to throw. It's kind of like being in a bad marriage, right? You just take anything you find and you throw. So there's no requirement as to what you can actually throw. It's a free will. Well, of course, if you want to, you could create an error object. Well, let's just look at this for a second. And in this case, of course, if you send me a less than 0, I'm going to go ahead and say caught, and the exception I'm going to get over here is going to be the exception you sent to me. And so you can see gave 0, blah, blah, blah. Or you can also say new error. There's a little bit more civilized. And you could throw an error object, and that becomes an error object you're throwing, which is perfectly fine if you want to throw. So exception handling follows a very similar thing. Because you don't have the type information available in the catch, how do you know what type of exception you're really throwing? Well, if that becomes really important, you could try using an instance of, but that's not very common or traditional. You just deal with exceptions and then work with it. Hopefully the function has limited set of exceptions it can throw. We talked about a lot of different things in here about JavaScript in general. ES6 solves quite a number of these issues, but for its own purpose, it also introduces a few other issues you have to deal with. In general, though, what do you do about code and code quality? One of the things is when you write code, I'm a huge fan of code reviews. When I write code, I want somebody else to review my code. When somebody writes code, I want to review their code. But in general, I tell people, before you have a human being review your code, run the code through a series of tools, because I would rather have tools tell me my code sucks before my coworkers tell me my code sucks. And the beauty of that approach is, if I run it through my tools, then the number of things my coworker is going to find out is a little less and of better quality. If I don't run through a tool and give it to my coworker, they're going to be bogged down by telling me obvious things that a tool could have told me. So generally running through a tool is a good idea. A good tool can also find some errors for you early on. One tool is JSLint, and JSLint was written by Douglas Crockford. I highly recommend his book. It's a really good book to read. But JSLint is maybe a tool which is a little too hard on programmers. If you're going to use JSLint, my recommendation is sit down, because it will insult you. And it will continue to insult your entire ancestry and call bad names. If you're a person who doesn't like to take abuses, you're going to be really upset. If you have very thick skin, then it's like, bring it on, I'll deal with it. But some people just don't like such kind of hard-lined approach. And so one person kind of said, no, I don't really like it. So went on to create what I would say is a better tool called JS Hint. And JS Hint is a lot better than JS Lint. Both the JS Lint and the JS Hint will scold you, will slap you, and will call you names. But in the end, the JS Hint will come and hug you. That's the only difference. So you can customize it a little bit better. So I really like using JS Lint. You can run it fairly easily from command line tools, which means we can integrate that in CI environment very easily as well. So I would highly recommend running it through these tools, and you can customize it to what kind of things you want to observe and be reported from it as well. You can take a look at it. So if you're interested in downloading the examples here, you can visit my website, agiledeveloper.com, and you can download it, please.
Just a comment, now there's also TS hint. So like
Yep.
everything you said in the beginning with the double equals, you can also catch in TypeScript now.
Yep, absolutely. Yes, definitely I would recommend, at least for those reasons, I would definitely recommend using those tools. It is nice to be caught. You know, I'm not perfect at all, and I rely on these tools to, you know, help me to get better. So, and I think that's the right way to do. I don't believe in perfection of human beings. We are creative. We are cool that way. We don't want to become boring automatons where we are perfect in what we do and lose creativity on the other side. I would rather be goofy and creative and then let the tools help me to get better. So I'm all for it, absolutely. So that's the link to, yep, go ahead, please.
Just because we have that view again, many bad examples on the web.
Yep.
Sources for good examples.
There are a few. I would say look at some of the good projects that you can download. I like to read code and understand from good code. So look at famous frameworks or famous tools that is widely used. I also look generally for tools where there is a decent amount of automated testing with it. That usually kind of is a sign that the developers are paying a little bit more attention about quality of code as well. So I would say look for those things. Definitely, I would say Douglas Crockford's book is a must-read in my opinion. I always make fun of his book. There was somebody who tweeted this. This was really a funny tweet. They put JavaScript, the definitive guide. The spline of this book is this thick. And then next to it, they put the good parts, which was that thick. And they tweeted saying, this is all you can do with JavaScript. This is all you should do with JavaScript. So I think that's a really, I make fun of this book a lot of times. I say, the book is 96 pages, but it has 4 pages of good things and 92 pages of you shouldn't do these things. But I really like the book. It's a good book to read, definitely. And there are a few other books. One of the other books I would actually recommend also is a book called JavaScript Allonge. And JavaScript Allonge gives you some flavors of writing JavaScript in ways we normally don't think about. So if you're really interested in writing very fluent JavaScript, look at JavaScript Allonge. That's another book to look at. So I hope that was useful. That's all I have. Thank you.